Let's try a slightly different example. First, let's write out a general formula for the fourth degree Taylor polynomial of a function f of x at a. This problem isn't meant to be tricky. We can just write down the first 5 terms of the Taylor series to get t sub 4 of x is equal to f of a plus f prime of a over 1 times x minus a, and you keep going until you get to the fourth derivative of f at a divided by 4 factorial times x minus a to the fourth. So that wasn't so hard. But now for part B, suppose that the fourth degree Taylor polynomial of some function f of x at the point a equals 3 is given by 2 plus 2 square root of 3 times x minus 3 plus 10 times x minus 3 squared plus pi times x minus 3 cubed plus 3 times x minus 3 to the fourth. And now the question is, what is the second derivative of f at 3? Well, let's compare the Taylor polynomial we were given with the general formula we wrote down in part A. Where does the second derivative of f show up in the general formula? It shows up here, right before the x minus a squared. Therefore, if we want to find the f prime of 3 in our current example, we should be looking at the coefficient of the x minus 3 squared, which is 10. The final answer is not 10, however, because the coefficient in the general formula is f double prime of a over 2. Therefore, we have to set these coefficients equal to each other, and we get that f double prime of 3 over 2 is equal to 10. And then we can solve to find that f double prime of 3 is equal to 20. And this is our final answer.